everyone, welcome to Education for the Next Generation. This is D. Mallikarjun Rao, physics teacher. Today we are going to discuss about refraction of light at curved surfaces. To understand the refraction of light at curved surfaces, first we need to recollect what do you mean by refraction. Refraction means whenever a ray of light entering from one dispersive medium into other dispersive medium, the ray of light bends at the plane separating the two media, and this phenomena is called refraction of light. So, here there are two different media, one is the rarer medium, second is the denser medium. For example, this may be air or this may be water. Now, PQ is a ray of light entering from one dispersive medium into other dispersive medium. If other medium is not there, the ray of light may travel in the straight path, but because of the presence of second medium which is denser, the ray of light instead of traveling in the straight path, it bends and travels in the direction of QR, and this phenomena is called refraction of light. So, here in the first case, the ray of light is entering from rarer medium into denser medium. In this case, the ray of light bends towards the normal like this. This is the actual path of the light ray. Since it is traveling from rarer to denser, it bends like this. So, you can write towards normal. In such case, angle of incidence is greater than angle of refraction. This is the more angle, this will be the less angle. I is greater than R, and this is true when a ray of light is entering from rarer medium into denser medium. Let us come to the second case. If at all a ray of light is entering from denser medium into rarer medium, in this case, instead of traveling straight path, the ray of light deflects away from the normal. This is the actual path, and that deflects like this. That means the angle of refraction is increased. So, here you can write away from normal. That means whenever a ray of light is entering from denser to rarer medium, it bends away from the normal. In such case, angle of incidence is less than angle of refraction. This is the big angle and this is the small angle. So, it may be from rarer to denser or denser to rarer, the light ray definitely bends. Particularly in the case of rarer to denser, the light ray deflects towards the normal, whereas in the case of denser to rarer, the ray of light deflects away from the normal. Here in the first case, rarer to denser, angle of incidence is greater than angle of refraction. Here the angle of incidence is less than angle of refraction. So, this is the basic information about the refraction of light. Let us see what do you mean by lens. Lens is a transparent medium with spherical boundaries. Lens is a transparent medium with spherical boundaries, and we have two types of lenses. One is the convex lens, second is the concave lens. There are two types of lenses we have. One is the convex lens and the other one is the concave lens. Let us see how a convex lens is formed and how a concave lens is formed. Let us assume two halo spheres intersect each other like this. Two halo spheres with centers C1 and C2, they intersect like this. And this intersected portion, let us fill the intersected portion with any transparent material, and if you separated this portion, you will get the shape like this, and this is called as convex lens. So, convex lens is thin at the edges and thick at its center. Convex lens is thin at the edges and thick at the center, and this is the convex lens. On the other hand, concave lens, how it is formed? Let us keep two halo spheres with centers C1 C2 very close to each other, and the gap between the two spheres is filled with a transparent material, and that is separated out, and this shape is called as concave lens. So, concave lens is thick at the edges and thin at its middle, quite reverse of the convex lens. Convex lens is thin at the edges, thick at the middle, quite reverse. Concave is thick at the edges and thin at the middle. So, this is convex and concave lenses. So, lens, this is a lens and this is a transparent medium, maybe glass, and that is covered with two curved surfaces. This is also transparent medium covered with two curved surfaces. So, these two are the lenses. The definition, the meaning of lens is, it is a transparent body with two curved surfaces. Here, this is a transparent body with two curved surfaces. So, it is a lens. This is also a transparent body with two curved surfaces. So, that is also a lens. Basically, if a lens which is thick at the middle, thin at the edges is convex, thin at the middle, thick at the edges is concave. This is the basic information related to convex and concave lenses. Let us see the important points of lenses. The first important point of the lens is its optic center. This is the convex lens, this is the concave lens, the geometric midpoint of the two lenses. This is the geometric midpoint of the convex lens and this is the geometric midpoint of the concave lens. The geometric midpoint of the lenses is called optic center and it is denoted by the symbol O. So, O stands for optic center of the lens. It may be convex, it may be concave. The second important point is center of curvature of the lens. The center of curvature is denoted by C or 2F. Both are the symbols for center of curvature. Let us see the meaning involved in the term center of curvature of the lens. Here, this is the convex lens and this is the curved surface, one curved surface, and actually this is a part of the big sphere and this sphere has a center. Similarly, this curved surface of convex lens also is a part of a big sphere and here this is the center of the second sphere. So, taking from left to right, this is the first curved surface. Corresponding to this first surface, we have the center here. Corresponding to second curved surface, we have the center here. So, corresponding to this curved surface, this is the center of curvature. Corresponding to this curved surface, this is the center of curvature. So, basically, the meaning of center of curvature is, it is the center of the sphere in which the curved surface of a lens is a part. Here, this is the curved surface of the convex concave lens and this is the whole sphere. 2F is the center of the particular sphere. This is the second curved surface of the concave lens and this is the whole sphere and this is the center of the sphere. For the first surface, this is the center. For the second surface, this is the center. So, the center of curvature of the first surface is given with the symbol 2F. Center of curvature of the second surface is given with 2F dash. Here also, center of curvature of the first surface is 2F. Center of curvature of the second surface is 2F dash. Here also, center of curvature of the first surface is 2F and the center of curvature of the second surface is 2F dash. So, basically, the meaning of center of curvature is, it is the center of the sphere in which the curved surface of a lens is a small portion. So, that is the definition of center of curvature. And now, the third important point is principal axis. Let us join 2F dash O 2F with the help of a imaginary line. Let us assume an imaginary line passing through 2F O 2F dash. Here also 2F O 2F dash. This imaginary line passing through center of curvature, optic center another center of curvature, this imaginary line is given the name principal axis. So, principal axis is an imaginary line passing through optic center and the center of curvature. So, the three important points here are optic center is the geometric midpoint, center of curvature is the center of the sphere, and the line joining center of curvature and optic center is called as principal axis. These three are the first three important points of the lens. The fourth important point of lenses is its principal focus denoted by the symbol F. This is the convex lens, optic center, focus, center of curvature. So, let us assume a ray of light moving parallel to the principal axis. After passing through the lens, this light ray converges through a point on the principal axis called principal focus. So, this is the convex lens. Here I have taken a ray of light passing parallel to the principal axis. After passing through the lens, it converges through a fixed point on the principal axis, which is called as principal focus. That is the definition, the meaning in the case of convex lens. Whereas in the case of concave lens, this is the ray of light passing parallel to the principal axis. After passing through the lens, it diverges like this. And if you extend the diverging lens in the backward direction, it apparently diverges from a point F. It apparently diverges from a fixed point on the principal axis called principal focus. Here, in the case of convex, the light ray really passes through F, really converges through the focus, whereas in the case of concave, the ray of light apparently diverges from F. In both the cases, we will call this point or that point as the principal focus, and this is the principal focus of the convex lens, and that is the principal focus of concave lens. After that, the fifth important point is the focal length, denoted by the symbol small f. The distance between optic center and focus is called focal length of the lens. It may be convex lens, it may be concave lens, but the distance between optic center and focus gives you the focal length of the lens. Focal length O to F is equal to F. F is the symbol for focal length. Now, next one is radius of curvature. Radius of curvature is the distance between optic center and center of curvature, O to 2F. The distance between O and 2F is called radius of curvature in the case of convex as well as in the case of concave lens. So, what is radius of curvature? It is the distance between optic center and center of curvature. Optic center and center of curvature, that distance is called as radius of curvature. So, the most important observation